essentially two things I want to focus on. I want to get, if I can, sequences done today. So we're going to look at finding the limited sequence. We talked yesterday about the main, techniques for doing that. And I'm going to kind of tag on the formula thing at the end. So that's what we're going to look at. So when we're looking at finding the limit, there was brute force, right? You just make n infinite and hopefully get an answer. A second technique, no particular order, was L'Hopital's rule. And wasn't the third technique divide top and bottom by n or n cubed or n squared? And you apply the one of those three, depends on the situation. So this is my version of 16. If you look at your version of 16, it might not be quite the same because that's what WebAssign does. It switches the questions around so that in a way everybody's getting their own version. But now, a question like this, I'm going to be asked to find its limit. So what does the sequence look like when n goes to infinity?
Well, n would it would approach 0.
Yeah, it would. And wouldn't the technique to prove that? Because you got to know that when you do WebAssign, you just type in 0. It doesn't ask you to show any working. But I want you to get really good at doing working, because when you get the test or a final exam, you're going to be writing this down like I am. You're about to say, I hope.
Well, plug infinity in for all of your n's.
Yeah,
and then
you're going to do brute force. And that's what I want to see. Right? So you got to prove it to me, even although WebAssign doesn't say prove it to me. Now, to me, proving it in this case is just simply writing down the working that brute force is. You don't need to say here, I'm now about to use brute force and do it, right? You just write it, we're cool, right? We good? Yeah. Okay, let's look at another one. And this one is version of 17. And we're going to find the limit as n tends to infinity. And the sequence this time is 6n squared, take away 5n, and underneath it is going to be 2n squared plus 1. Now, you should know that the answer to that's 3 just by looking at it. Would you agree? Can you look at it and say 3? And in WebAssign, won't you just put 3 and move on? Probably. But I want you to, I'm saying it again, I want you to get used to proving this. So you got to prove this to me. Are you going to prove that this answer is in fact 3?
I'd probably use L'Hopital's rule.
That would work. If you did L'Hopital's rule, you would do it twice and you get the answer, and I'm totally cool with that. But I'm not going to.
By a power of n.
Yeah, I would do that. Not that the L'Hopital's wrong, because it's not. I would just choose this method because I think it's cleaner. 3, 5 over n, 2, 1 over n. And I will just put you on mute for a second. So here we go. Come on. I think I got you. So you'll have to hit the space bar. I know it's probably. Come on, computer. It's just being a pain in the posterior. Right. And at this point, 3 take away 5 over infinity, 2 plus 1 over infinity, 3 take away nothing, 2 plus nothing. What did I just do there? Nobody noticed my mistake. There we go. Yeah, I got the answer 3. Halfway through, I changed a 6 into a 3 for some reason. Probably because I get distracted. We cool with that? Brute force? Could do L'Hopital, nothing wrong with that. Could divide top and bottom by n squared. Let's see if I can find. You never find things unless you want them. Let's do this one. This is 26. The sequence is written down like that. Right. You know that's the same thing as just saying that.
Is that 4n on the bottom?
Yes, it is. So 4n. So I'm going to, well, what technique am I going to use?
L'Hopital's.
Is that the natural log of n over the
Yeah.
natural log of 4n?
It is, and I am going to use L'Hopital. So it's going to be the limit as n tends to infinity of the natural log of n over the natural log of 4n. And since I'm going to do L'Hopital, I'll put a little L to tell people that's what I'm going to do. And if you differentiate a log, you get 1 over n. And if you do the log of 4n, remember last time, what is 1 over 4n going to be finished with? If you differentiate the log of 4n, you don't just get 1 over 4n.
Chain rule.
So you get an extra times 4, don't you? Which in this case, you get that, and I'm getting deja vu here. The answer just ends up being 1. Okay. So that is how I would tackle that. I could tackle that slightly differently. I don't think this is a very efficient way of doing it, but just because I can, let me show you how someone else's brain may work. They have a look at this question and they say, okay, I'm going to have to prove or find what its limit is. And they decide to go this pathway. I don't think it's a very efficient way, but that doesn't make it wrong. It's the first thing they did is they might say, well, I'm going to split it like that. And then they're saying, you know, you can divide the top and bottom by n or n squared. But really, there's no reason why you can't divide the top and bottom by anything you like. And so I'm going to divide the top and bottom by the natural log of n. And what we now get is when you divide that by that, you get 1. You divide, don't know why that's a 4, it's an n. You divide that, oh, that is a 4. Take it back, that's a 4. You get the natural log of 4 over the natural log of n plus 1. And then you do brute force. Isn't the natural log of infinity infinity? And what do we get? Well, the log of 4 is a number divided by infinity gets me 0. And there you go. Would you say that's less efficient? Let's phrase it that way. I'm still getting the right answer. Maybe in some of your brains, it makes more sense. I don't know. Good news is that if you did that in the test, you'd get all the points. The question is, find the most efficient way. That's not the question. The question is, just prove it to me. What you cannot do in a test is just say 1. Or you might say, well, I got the right answer. Math might seem, engineers, the answer is important, right? That's what they want, right? They want the 42 at the end. And maybe sometimes are not so interested in the logical proof that got you to 42, as long as 42 is correct, right? And mathematicians are more interested in the process being correct. And it's nice to get the right answer, but the process is what's important. And you could simply just cheat. If I wanted to know what the log of n over the log of 4n would be for a very big number, right? N tends to infinity. I could estimate it like this. I could do the natural log of 1, 2, 3, 4, 5, 6, 1 million divided by the natural log of 4 million. Now, do you see that answer is about 0.9? Right, if I upped it to say 1,000 million, you know, I might get 0.987. If I did it to 2 billion, trillion, zillion, zillion, million, whatever, you know, as soon as I get fed up hitting zeros, won't the answer come to 0.9998? And I'll say, yeah, the answer's 1. And I go to WebAssign and I stick in 1. not because I proved it, but because I know that when things are really big, the answer that you get is very close to what the limit is. If it has a limit, of course, right? That's not the way to do maths. That's the way to do engineering, right? You want to do something, just stick in some numbers and see what's happening, right? And hope the bridge doesn't fall down. Okay, it came to me, so I'm going to tell you this joke. Olympic College engineers, Harvard engineers, and MIT engineers all end up in the finals. And what their project was to design an aircraft, and Boeing decided to pick the winner. And so the professors of the students who designed the aircraft were invited, and there's 3 of them, right? There was an Olympic College professor, there was a Harvard professor, and there was an MIT professor. And they're all sitting in the aircraft, this brand new aircraft, and they're sitting in it. And the guy from Boeing came in and says, well, I've got good news to tell you. And he says, one of your team has actually won, and we secretly built their aircraft, and you're sitting in it right now. And the Harvard guy gets up, and the MIT guy gets up, and they run out screaming, panicking, right out the aircraft. And the Olympic College professor, he's sitting there smiling away. And so the Boeing representative says, why are you still here? Why are you smiling? And he says, look, if it was my students that designed it, this plane is never leaving the ground. Well, are you an engineer? Because you seem to like that joke.
Well, I'm studying engineering, and my grandfather actually was an aeronautical engineer and worked for Boeing for quite a long time.
Oh, so you might want to tell him that.
Well, he unfortunately passed away, but no, there is a good story about something he did at Boeing, but I'm not sure if we have time for that.
Hold that thought, because I love stories and jokes, so we may do that another time. Okay, are we comfortable, guys, with the techniques that we've used here? So all I want to do now is nip over to the homework, and we'll show you some questions, and we'll talk about which of the methods would be the best one to find a limit, right? So you're going to say to me, yeah, brute force would work on that one, or divide top and bottom by n squared would be the way to go, or L'Hopital, right? You don't need to worry about, you might come up with some really cool one-off techniques like I did here, and I'd love to see them when they work. They're kind of cool, but there's no need for you to go and think outside the box unless you want some fun to do it, right? The 3 methods that I've explained are going to be fine for the types of situations you're going to do. So, you know, I love insulting engineers. And mostly it's because I've taught so many of them, and they tell me horrible things like, you know, in a couple of years, I'm going to be making twice what you make. That's just not right, is it? But then I can say to them, I'm going to have twice as much fun as you, so that makes up for it. Okay, let's get this show on the road. Okay, suppose I'm just jumping around here. Suppose I was doing question 27. Which one of the 3 methods would I be using on that guy?
I probably use L'Hopital's rule because it generally almost always works.
Yeah. Wouldn't you call that guy n squared on the top and e to the 5n on the bottom, right? So sometimes you have to tweak it. 28 is actually basically the same question, so I won't do that one. What about 29? Because you know that they're making life a little bit hard for you here. Ah, I got you puzzled.
Brute force.
Unfortunately, infinity takeaway infinity is really not going to help you, but it's a choice. Okay, so let's kick out brute force right now. Okay, I'm writing that one down so we can zoom back to it then.
Could
I'll
you
Oh, keep
factor
going.
out the, or not factor, could you break that natural log apart? The natural log of, I think it was n+4, and then divide by natural log.
I think you're close. What you said didn't quite gel with what I thought, but maybe it's just I wasn't paying enough attention. Can't that be written as that? You got to sometimes figure out that the guy you've got in front of you, the light bulb Molly, right? Sometimes the guy that's in front of you ain't the guy that you're going to actually need. Sometimes you have to play about with it. Remember the n squared e to the minus n thing had to be written that way. And when it's written that way, L'Hopital. Do you see this one? You could do a quick little L'Hopital in the middle and then just take the log of it. Or you could divide the top and bottom by n and take the log of it. Both techniques would work. For instance, if I did this one, oops, there's a nice little rule that says you can just bring out the log and just get the limit of what's inside the log. Now, would you agree you could do that with L'Hopital? You could divide top and bottom by n. Can I just tell you that the answer to that's going to be 1? And so the log of 1 ends up being 0. Does that make sense? The natural log of 1, that's what 0. So yes, we have 3 techniques. And if it was just simply, they're all good to go, wouldn't that be too easy for you? Though they're not going to make all of them that easy, right? So what we're looking at now are the sneaky ones. So let me find some easy ones, and then we'll talk about some sneaky ones, right? So don't overthink the next couple of questions.
Looks like there's a question in the chat.
Oh, thank you. I don't get to see those things. If you write log, it means log to base 10. If you write ln, it means natural log. That's the answer to that person's question. And okay, let's, I know, I think I'm sharing it. Yes, I am. Here we go. Suppose you were doing question 22. Would you agree brute force would work really easy on that? And the answer is 0. Question 22. I should probably zoom up a bit. Would you agree that question 16 is brute force? Do you want to move up a bit further? No, that's not limits anymore. I think we did 17, that was 3, so I can skip that back. What about 18? Which one of the 3 techniques would we use on 18? Or you tell me a technique that works.
Wouldn't you do the factor of n?
Yeah, I'd probably divide top and bottom by n cubed or n to the 4. What would you pick?
N cubed.
Yeah. Can you trust me? Eventually the answer is infinity. But when the answer is infinity, you don't click on that box and type infinity, which you can actually get from this little thing. You type in that word there. Right. So if the limit doesn't exist for whatever reason, it doesn't exist. You stick that guy in, right?
So I was
yes.
always told, or I remember being told that instead of it being called just dividing it, we call it factoring out the ends, which I guess you're then factoring them out to divide them.
Oh, just a different way of looking at it. I mean, if that makes sense to you, do it that way, it's totally fine. I just think divide top and bottom because to me that works for my brain.
I mean, it's what you're doing it the same thing either way.
Yeah, you're doing exactly. Mathematically, it's the same. Yeah. Oh, that's a good one. Question 20. L'Hopital? Divide top and bottom? Brute force doesn't work because you get infinity over infinity. What method would you use?
I would divide top and bottom.
By,
N to the 1/2.
yeah, square it in. Could you do L'Hopital? Actually, this one L'Hopital would work. Normally, you keep away from square roots when you do L'Hopital, right? L'Hopital and square roots don't play well together, but this is an exception to that rule. 21 looks horrible, but the answer is actually 1. So how do you do 21?
Well, if you consider the power that e is being raised to, which is -7 over the square root of n, as n
Mhm.
approaches infinity, you can just brute force that, and it's going to go to 0.
Mhm.
Then as the power that e is being raised to goes to 0, that's going to go to 1.
Yep, bang on. Couldn't have said it better. Would you agree? Brute force. Skipping by that one, there's a reason. Oh, there's a sneaky one. Okay, we're entering not so much the obvious ones, right? They're getting harder now. What about that guy? Don't do L'Hopital. That square root in the bottom would not end well. Trust me, it will not end well. So throw that one out. Actually, brute force is no good. Let's throw that one out. Okay, so you've only got one technique, divide top and bottom. I guess the problem is, what do you divide the top and bottom by? That's the puzzle. What would you divide the top and bottom by in question 24?
I don't know if this is right, but I squared everything to get rid of that square root, and then I divided top and bottom by n3.
And then to finish, I like your thinking.
To finish.
Right, let's say you do that and the answer's 4. What should you do to complete the result? Molly's got a light bulb.
You would have to take the square root again.
And you'd have to take the square root again to compensate for the fact that you squared it. So what you said, Christian, was perfect. A good start. Let me show you, because sometimes saying's not the same as saying, right? So I like what Christian was doing there. It actually was not the way I was going to do it, but I liked the way he did it. So if I picked him up correctly, and I think I did, we have got this fella here. And I'm putting words in Christian's mouth, but his brain is thinking, don't like square roots, pain in the butt, hard to work with. So let's square everybody. And I'll call this guy Bn, right? Because he's now a different sequence. Can I find the limit of that guy? Yeah. And in this case, if we find the limit of this thing as n tends to infinity, can I just tell you, if you divide top and bottom by n cubed or whatever, can you just take my word for it? It ends up being infinite, right? Now, in this case, what you then have to do is to make sure that you take the square root of that. Okay, the square root of infinity is still infinity, but can you imagine that might be a 4 the next time, or a 9 or a 21? And don't you have to compensate? Because if you square something, don't you have to finish by undoing that process? Okay, well, the square root of infinity is still infinity, so I guess you didn't notice the difference. But in a different world, can I change this question? Say that was an n to the 4. That's probably a bad choice. Suppose, yeah, you had something like that, right? Can you imagine that that would become 16n to the 4 over n to the 4 plus 6n? You'd end up getting 16, but the right answer would have actually been 4, because we squared it to get to there, and we have to square root it, right, to get back again. That was a cool technique. I like that technique. The way I was going to do it is much uglier, which is why I like his method better. In the original question, which I've murdered because I've changed it, was this guy. Is I was going to divide the top and bottom, and I was going to divide them like that. And that would have given me n to the half, and it would have given me the square root of 1 plus 6 over n to the half, which is that. And that would have eventually gave me infinity. So I would have got the same answer, but that's not obvious. Do you know why I chose 3 halves? Molly, do you want to tell the rest of us? Why did I choose 3 halves?
Well, you couldn't do n squared because the denominator is technically smaller than n squared. It would have had to be n to the fourth under the square root. So if you can figure that out, you can figure out that the denominator has the lowest power.
Right.
So then you basically take n cubed to the 1/2.
Like it. It's good. Okay, let's return to our little list of things. One of the skills that you bring to calc is algebra skills, manipulation, being able to see things in different ways, algebraically at least. Just like that. My thought process was not thinking of squaring, but it's cool. I love people who come up with good ideas. That was a cool idea. Right. Suppose you're doing 25. Where are you going with this one? By the way, the answer is e to the power of 7. How are we going to get there? How are we going to prove it?
I would do a similar process and take the natural log of the function, and then at the end raise e to that answer.
That would work. Couldn't you just think, nothing wrong with that. You should do that in a test, you're getting the points. My brain is saying 7n on the top over n plus 7. Let's just find the limit of that, which is 7, and then stick an e after the event, which is not that dissimilar, right? So what's that phrase? There's more than one way to skin a cat, right? There can be more than one technique that will allow you to get a valid proof, right? Something that does logically make sense. Now we're entering a couple of special cases. So I'm going to leave these guys for a few moments, go back to my notes, keep track of the time. And what are these special cases? Well, you know, all sorts of little things that you just get told. So I'm going to tell you something, which I hope makes sense. If a is a number and it's less than 1, then the limit as n tends to infinity of a to the power of n is going to be 0. So what would that look like? We can assume that that is going to be 0. Does that make sense? If your number, your base is less than 1, as you raise it, cube it, 4th power it, 20 millionth power, won't the answer just disappear to 0? Does that make sense? Now, I'm not proving that in any real sense. I'm just saying to you, it's an obvious truth, right? That any number that's less than 1. On the other hand, if a is greater than 1, then the limit as n tends to infinity of a to the n will be infinity. An example of that would be the limit as n tends to infinity of 7/3, right? That's about 2 1/3 to the n. Does that make sense that if you've got a number that's bigger than 1 and you raise it to the power of n, would you agree that that particular guy would eventually just get bigger and bigger to infinity? So can we just take that as a truism, right? I don't need to prove it, I just need to use it. Right? Now there's one guy I've missed here. 1. Right? Well, 1 is kind of interesting and at the same time kind of boring. Can you see that actually has an answer? Isn't 1 to the power of n pretty boring? Because 1 squared and 1 cubed is still 1, so its limit is 1. I mean, it might seem a bit strange, but it is. So far, so good. So what's going to happen? If we make the a value a negative number, okay, what would negative 7/8 to the power of n get you if n got bigger and bigger and bigger? What would its limit get you?
0.
Now, it'd get to 0 in a slightly different way. Wouldn't this one get to 0 if I kind of plotted it? It would be there, then it would be there, then it would be there, then it would be there, and then it'd be there and there and there, right? It would look like that if you sketched it. Wouldn't this one here look a bit more like it would get to there, then it would get to there, then it would get to there, and then it would get to there, and then that. You see, it would kind of zigzag plus to minus, but wouldn't each iteration of it be smaller than the previous one? Would you agree this one is even weirder? Because I can't really write infinity here. Because won't it also bounce between plus and minus infinity? It will get bigger and bigger, but the next big thing will be negative, and the next big thing will be even more positive and big, and even more negative than the last one was, but bigger. So divergent is a much better term than using infinity. So you notice that in WebAssign, you just write the word divergent, because it'd be a bit hard to tell me easily what the heck that was. Wouldn't it just easier to say it's divergent and not get into the details of what's wrong with it? So rule number 1 is this rule, right? There we go. Now, the next guy I'm going to get you is a very special case, and it's question 30, and it's a limit as n tends to infinity of cos squared n over 4 to the n. And we are going to use this special case. This is a very special case. And I am going to use a very dangerous thing in math. It is obvious. Because when we do things in math, we have said so many times in the past, it is obvious, and then somebody comes along and proves to us a special situation where if you use your obvious logic, it, it's wrong, right? But we're going to use it anyway. Would you agree that cosine of n is only going to be a number between -1 and 1? Would you agree then that cos squared n is only going to be a positive number from 0 to 1?
Yes.
Great. So would you agree that this fella will probably behave very much like that fella in the worst case scenario? And in most situations, isn't it going to be smaller than that guy? So I could write it, if it makes more sense to you, like this. Are you happier with the logic of that line? Okay. So do you recognize this fella? As the same thing as that fella? Couldn't you call the 1 1 to the power of n and it wouldn't change its value? And what do we know about this guy's limit? We just finished doing them a minute ago.
It's
If
0.
a, it's 0.
0, yeah.
Now, over here, would you agree that this thing is always positive? cos squared is positive, 4 to the power of n is positive. It's always positive. Now, the guy I want is this guy. He has to be between 0 and 0. Agreed? If you have to be between 0 and 0, what would be the logical conclusion to that?
Would be 0 because of the squeeze theorem.
Correct. It's called the squeeze theorem. Yes. Do you like that special case? Now, is that the only way to approach that? No, I'm sure you could probably come up with some quite cool ways, as long as they're mathematically correct, to come up with a similar result. Now I'm going to show you, well, I'll write it down because it saved me jumping back and forward. We're being asked to do, so we're now back to, you got to think hard. Right. No, this is not a squeeze theorem question. I need to algebraically write this down as a fraction. And I'm going to do that Sherlock Holmes thing. Once you've eliminated all the other possibilities, whatever is left must be the truth. So let's eliminate the possibilities. Would you agree brute force is probably not going to help you? Would you agree you can't really divide the top and bottom by n or n squared? There's no obvious way that that's going to happen. So who is left? L'Hopital is left. So this must be a L'Hopital question. But L'Hopital needs a fraction. And I don't have a fraction. So I've got to make one. I'm not going to do anything with that guy. But I might be able to do something with this guy. What would this guy look like if you put him on the bottom?
4 over n.
So we have taken this limit and recreated it algebraically as this equivalent, right? This and this are algebraically the same thing. Now I can do L'Hopital. And you got to be careful because there's a lot going on here. If you differentiate sine 4 over n, you will get the cosine of 4 over n. But won't you also, because it's a chain rule, get times the derivative of 4 over n? Okay? And the derivative of 4 over n, you'll trust me on this, is negative 4 over n squared. You check that later for your own benefit. Now divide the bottom, which is also 4 over n, and its derivative is negative 4 over n squared. So far, so good. Now, just for ease of seeing, I'll put little brackets around those guys. Do you see a guy in the top cancelling out a guy in the bottom? So now what we have got is a limit as n tends to infinity of the cosine of 4 over n. And now I'm going to do brute force. Well, that's going to be the cosine of 4 over infinity. The cosine of 4 over infinity is the cosine of 0, and the cosine of 0 is 1. Sneaky. Let's try and do maybe hopefully a more successful version than I did last time. Okay. Let's pick 1 million. Okay. So 1 million divided by 4, which is that guy, times the sine of 4 divided by 1 million. Now, when I hit enter, fingers crossed, I should get a number down close to 1, if this is correct. Oh, am I good or am I good? Now, the answer isn't 1. The answer is probably 0.429 and an 8 and a 7 and a 6. But the poor calculator can only work to a certain amount of accuracy. And, you know, once it goes beyond whatever it is, 16 decimal places, it just gives up and says, ah, the heck with it. It's 1. Now, can you see why that is going to be a problem in a test? Because you're going to just tell me the answer is 1 and I'm going to give you 0 points. Telling me the answer 1 is just a matter of hitting some buttons in a calculator, right? You could probably do that with every single question that we've done today. That's not what math is, right? Math isn't, I'm good at hitting buttons on my calculator. I don't know what the heck I'm doing, but I can hit buttons on my calculator. You're proving nothing when you do that. This is the cool stuff, right? That you could show me that it's 1. Not calculator version, but a real proof. I think that was cool. We're not going to get finished, but that's fine, because I want to give you another special case. Right, the last special case I gave you was basically the squeeze theorem, right, in all its glory. Here's one that you have never seen before, I think, unless you've taken this class before. I am just telling you that is true. You can actually prove it if you want. You can go online and see proofs of it. It uses limits and logs and Taylor's theorem and all sorts of stuff that you haven't got to. But actually, by the end of this course, if you ask me to, I'll prove it to you, right? But this is a kind of, you're using it right now and we'll prove it in the future if you want to get it proved. So put numbers in here to show you what I'm getting at. One plus 7 over n raised to the power of 3n is 3 times 7 is e to the power of 21. And it is because I'm telling you it is. But if you ask me at the end of the quarter, I'll prove that formula to you, right? But can we just accept it as being true right now?
Do we have, if we have that on the test, do we have to write?
Yeah, that's easy. If you get that one in the test, you just say e to the 21 and move on.
Okay.
Right?
Is that
So,
something that we need to memorize the formula for, or will
Yeah.
that formula be provided?
you won't be provided. You have to memorize it. But your test is going to be open book, so you might just want to write it down on a piece of paper and go and hunt for it when you know you need it. Right? No. Right. That's pretty much it. It's pretty cool, isn't it? It's interesting that that's what it's equal to. So if I said to you, which I'm now about to do, question 33, what is the limit as n tends to infinity of 1 plus 4 over n raised to the power of n? What is the answer to that question?
E to the
E
fourth
to the
power.
4th.
E to the 4th. And this is not the question, but this is quite interesting. That was actually, I believe anyway, that's where that came from. Someone was trying to find that limit, and a really clever mathematician figured out that it was E. Now, we all know what E is, don't we? The special E. Let's do it on the calculator so we've got something to compare it against. Right, there's E. Right. And I'm saying that this fella has a limit of E. So let's do a million, right? N is a million. Let's see how close it is, because it's not that good, I believe, but I could be proved wrong. Actually, much better than I thought. Agreed? Pretty cool. say hi. Before you go, I'll tell you a little history.
There was
We all
somebody
know-
in the chat just before it gets buried. He said, if we write log on a test, will you assume that it means base 10?
Yes. And ln means obviously the natural base. Sir Isaac Newton, yeah, the guy that did gravity and the apple falling down and hitting him on the head fella, once said a very cool phrase I like a lot. You know how some scientists and whatever get really arrogant because they're so much cleverer than we are? And he was one of the like major brains in the world, right? You know, like the Einstein of his day. And one of the things I like about him is he was very modest, which if I had that kind of brains, I know my personality, I would be as arrogant as heck, but he wasn't. And he came up with this phrase and people were saying to him something like, what's it like to be so clever, to know these things that nobody else has known, you know, to figure out calculus and do all the other things. And he said, the reason I can see so far is I'm standing on the shoulders of giants. And what he meant there is he didn't create everything. He just used stuff that other people had found for him. And he used what they'd gave him. And he just took it like one more step. And I think that's a really cool way of looking at math. Math has got such a long history of structure, of people doing stuff and then somebody saying, hey, wait a minute, if you do this and this, there's something new. Somebody was the first person to solve that problem. And then once that person solved it, either the same person or someone else expanded it and solved this problem. And then math, the way we develop is somebody comes up with another bigger, harder problem, but they used all the things that came before. So it's kind of cool. Mathematicians are, for the most part, and I'm not even vaguely near them, they have some wonderful brains. Just to think the way their brain works would be great. I appreciate it, but maybe what some of you one day will be really cool like that. Right? Oh, don't shake your head. It could happen, Christian. You came up with a cool idea today. So, you know, maybe you'll have a breakthrough moment of inspiration one day. Whatever it is, will you tell me first? I'll write a paper on it and claim it was me, like Leibniz done to Newton.